this force here, and you need to have this force and this force. And to find this and these forces, we need to come back to this one here and this one here. So for example, if I just need By, then I could take the top part, and if I sum the moments about point, let's say here, A, that should be 0. If you choose this point, the only thing left is this force and this force. And what you get 450. The distance here is 1. And about this point, that force gives a moment, which is going to be clockwise. You place a negative sign and make it counterclockwise. Then this is going to give a moment. So you have By, and the distance from here to here will be 3/4 and a 3/4. And the actual direction is going to be counterclockwise. You take this as positive, and that goes to 0. So that should give us the force Py as 450 divided by 1.5 for 300 pounds, and it's going to maintain its direction going up. So just by considering this here, we found this force to be 300 pounds. Then we come here and we sum the force in X, and that should go to 0. So that immediately gives you dx as 0. And the moment you find that force, you can always replace this by 0. Then we need dy, which means you choose the point E and sum the moments about point E, and that should go to 0. Which means we're looking at 450. The distance is from all the way here to here. Looking at 1 plus 3/4, another 3/4, and the direction is counterclockwise, so we keep that as positive. Then we have dy, this is going to be 3/4, 3/4, and we make it counterclockwise, place negative sign, and that goes to 0. So that gives us the dy as 450 multiplied by, say, 1.5 and 1, that's 2.5 divided by 1.5. So this should give you 300, and comes out to be 750. Continues to go up. So we get this force as 750 pounds. And that's all we really need, because now I can come to the arm and I can say some forces about point C. And that should also go to 0. So we have 300. The perpendicular distance between this and this will be 3/4. So that distance 3/4. About this point, the moment here will be in the clockwise direction. So you make it counterclockwise, place a negative sign. Then we got P, and now you're looking at the distance 6 from here and another 3/4. So that's 675. It's going to be clockwise about point C. Make it counterclockwise by attaching a negative sign. Then we got this force here. So about same point, this will create a counterclockwise moment. So we're looking at 750 multiplied by 3/4, this will be plus counterclockwise, and that goes to 0. So that's going to give you P as 750 minus 300 times 0.75 divided by 675. And if you go through the calculations, this P comes out to be 50 pounds. And it came out positive, so it should keep going downward. So that's what you need to do for solving this problem. Now, there are a couple of things which you'll notice. First is, to find this force, you don't need to solve every force in this problem. I mean, technically, you could write 3 equations here to solve for this, this, and this. You write 3 equations here to solve for this, this, and this. And then you can come here and you can solve this, this, and this. I mean, each component being in equilibrium gives you 3 sets of equations, and you can solve for 3 unknowns. But as I said that before, that to find this force, you calculate only the forces which are needed. And what that means is that this force was never calculated. I'm sorry, not this one. This one was never calculated on the upper jaw. Then this force here was never calculated. Then these two were never calculated. So in a given problem, you need to really look at very carefully and then see what you really need. Like in here, we needed the force P. So you look at the actual handle and then see, to find this force, what other forces you need. It's like working your way backward. So when you work backward, I can see that to find this, I would at least need some of these forces. And once you made the choice for the point C, then it becomes very clear that this will be one of the forces which is needed, and then these two will be another sets of forces, those will be needed. Then you come back here and then you look at what you need to do to just find this force. I mean, you don't worry about the rest of them which are on the system. Same thing when you come here, you only worry about these 2 forces, and the rest of them you pretty much ignore. Yes?
I don't understand why you have dy and ey in opposite directions. But
Okay.
the forces at A and the forces at D are in the same direction. It seems to me that them would be in opposite direction too.
For